Creating 3D sketches in SolidWorks can take a bit of getting used to, but it's a skill that can be a big time saver if you have to design things like tubing, piping, or weldments. To begin a 3D sketch, you can use the 3D sketch icon from the sketch toolbar, or you can use the 3D sketch command from the insert drop-down menu. At first glance, not very much is different between the regular 2D sketch environment and the 3D sketch environment we see here. If you look closely, you'll notice a 3D sketch is listed in the Feature Manager tree, and the status bar reports that you're in fact editing a 3D sketch. Other than these indicators, the majority of the same sketch tools are available, including lines, arcs, rectangles, and splines. There's also a sketch tool available only in 3D sketches called Plane. We'll talk more about that in a moment. First, let's take a look at the basics of 3D sketching. I'll begin by selecting the Line tool from the sketch toolbar. Notice that red arrows show up at the origin matching the X and Y directions of the reference triad here in the corner. Also, next to the pointer, you see the XY indicator. This feedback tells me that if I start sketching a line, it will lie in the XY plane, which has the same orientation as the plane we call the front plane. Before starting the sketch, I'll press the Tab key on my keyboard. Watch what happens as I do this. The red arrows move into different orientations, and the indicator next to the pointer changes. You'll see the XY, YZ, and ZX orientations become active. This ability to change the active orientation of your sketch is what makes 3D sketching powerful. Instead of creating several 2D sketches and the reference planes that go along with them, you can use 3D sketches to accomplish 3D geometry in a single step. Here's a basic example. I want to begin in the XY direction. So if necessary, press the Tab key to be sure the XY direction is active. Next, I'll click on the origin to begin sketching a line. This line will lie along the Y direction. If I were in a 2D sketch, this would be the vertical direction. Next, I'll continue with the line segment in the X direction. So far, these segments lie in the XY orientation, and they're essentially a 2D sketch. Let's break out of the 2D plane by pressing the Tab key, making the YZ orientation active. Now, I'll sketch a segment in the Z direction. Using the Tab key again, let's make the XY orientation active again, and sketch a segment in the Y direction. To complete this simple example, let's add a segment in the X direction and turn off the Line tool. You can see as I rotate the sketch that I've got a 3D structure that could not have been created using a 2D sketch. In fact, to create this using 2D sketches, it would have been necessary to create two reference planes. Although what I've shown you so far may seem very basic, I do recommend you try using the Line tool along with the Tab key to create some basic 3D structures like this one. Many users struggle to understand the important role of the Tab key and become frustrated when trying to use 3D sketches. In the next lesson, we'll create a slightly more complex 3D structure along with relations and dimensions. In this lesson, we'll create a 3D structure similar to one that would be created for the design of piping or bent tubing. We'll create the necessary geometry using a 3D sketch, and we'll add the necessary dimensions and sketch relations to fully define the structure. To begin, let's create a new 3D sketch using the 3D sketch icon from the sketch toolbar. I'll use the Line tool and create a segment beginning at the origin and running along the X direction. When using 3D sketches, I recommend you pay attention to the length feedback next to your pointer. In this case, I want this segment to be 12 inches long. I'll use the feedback to make sure I'm close to this value. Not exactly 12 inches, but close. This will make it much easier to define the sketch later using dimensions and geometric relations. When the segment is completed, you can see it in Properties in the Property Manager. Notice a relation of along X has been automatically added. If it wasn't, I could easily select the Along X icon to add it manually. Next, I'll sketch a segment in the Y direction about 8 inches long. The next segment will be in the Z direction, so I'll press the Tab key to make the YZ orientation active. You'll see the YZ feedback next to your pointer, and if you pass it, keep pressing Tab until it reappears. The segment will be approximately 6 inches in the Z direction. Next, we're going in the X direction, so I'll press Tab to activate the ZX orientation and sketch a segment approximately 6 inches long. Next, I'll create a segment in the Z direction about 5 inches long, followed by a 5-inch segment in the X direction. Now, I'll create a small segment in the Z direction and then switch to the XY orientation to create a line in the Y direction. To finish the structure, I'll sketch a segment in the X direction about 12 inches long. Now that the shape of the structure is finished, let's add some definition to it. As you can see right now, it's mostly blue, meaning it is underdefined. I'll begin by adding some geometric relations, starting with the 2 long segments in the X direction. I would like for these to be collinear. I also want the 2 vertical segments to be equal. Instead of the equal relation, I can accomplish the same relation by selecting the upper endpoints of the segments and choosing the along X relation. Now I'll turn my attention to adding dimensions. Adding dimensions in 3D sketches is a little bit different than in a 2D sketch. I'll launch the Dimension tool and select these 2 points. When I do, Solidworks displays the vector magnitude or point-to-point length between the points. If I press the Tab key, you can see I have the ability to add dimensions in a single direction. The cursor feedback lets me know which direction the dimension is being applied in. I can toggle using the Tab key and dimension along the X, Y, or Z axis, along with the point-to-point or overall length. This makes adding dimensions to 3D sketches easy and intuitive. Also, notice that the dimension text is oriented on the screen with respect to the plane that it's being added in. This not only helps keep the graphics area looking clean, but also makes it easy to identify exactly which sketch entity or direction a dimension is controlling when you're making edits. I'll quickly delete this dimension and instead add a 1-inch dimension to the smallest segment of the sketch. Next, I'll define the gap between the 2 vertical segments. And I'll set it to 2 inches. Both horizontal segments at the bottom will be 12 inches. And the 2 longer segments in the top portion will be 6 inches. As you progress with defining a 3D sketch, remember you can always stop and drag the remaining blue geometry to find out what remains underdefined. I recommend you do this more in 3D sketches than in 2D sketches. The reason is that in 3D sketches, it's possible to add many relations that are redundant or unnecessary. Rather than adding relation after relation, check to see what else you really need to define. In this case, you can see I can drag the blue geometry up and down, so I need to put in the 8-inch vertical dimension. This makes the sketch fully defined. To complete this example, I'll add some fillets to break the sharp corners. And finally, I'll create a circular profile on a new 2D sketch to sweep along the 3D path. The diameter I'll use is 0.4 inches. In the previous example of a 3D sketch, the geometry we created lined up with the standard coordinate system. That is, all lines were either in the X, Y, or Z directions of the reference triad shown on the lower left-hand corner of the graphics area. In this example, we want to take a look at how to create geometry that does not fit into the XYZ system. This is the geometry I want to create. You can see a portion of the sketch lies at an angle of 45 degrees in relation to the top plane. Before I begin the sketch, I'll create a plane to serve as a reference. By the way, it's not necessary that you create reference planes ahead of time like I'm doing here. This is simply one approach. In the next lesson, we'll take a look at using planes created on the fly. To create an angled plane here, I'll begin by putting a line on the top plane and use it to define an angled plane at 45 degrees. If your sketch will require several reference planes, it's a good idea to rename them so you can identify them easily as you sketch. Here I'll simply call this plane 45 degrees. Now I'll start a new 3D sketch and activate the Line tool. As you saw earlier, the red arrows will appear indicating the orientation of the sketch. I want to create the angled portion, and I want to use the angled plane I just created to do so. Instead of just sketching a line, I'll turn off the Line tool and pre-select the angled plane. I can do this from the Feature Manager tree or the Graphics area. With the plane selected, I'll turn on the Line tool, and notice the red arrows are different now. They line up in the same orientation as the angled plane, indicating that the coordinate system I'm using has changed. Instead of the front plane serving as the XY plane, now this angled plane is the XY plane. I'll begin with a line starting at the origin and going in the vertical relation. Remember, vertical is in reference to the angled plane. Next, I'll sketch a horizontal line and another vertical line. Notice I'm snapping to the yellow inference lines to automatically capture vertical and horizontal relations as I sketch. Of course, these can be added later, but this saves me a couple of steps. Now that I've created the lines that lie in the angled plane, I need to create a short line that is perpendicular to the angled plane. To access this direction, I'll use the Tab key to sketch a line along the Z direction. Next, I want to sketch in the same orientation as the top plane, so I want to stop using the angled plane as a reference. And to do this, I simply turn off the Line tool and turn it back on. The red arrows now line up with the reference triad once again. I'll continue with the geometry. And to complete the sketch, I'll click on the origin. Notice that although I was sketching in the orientation of the top plane, by clicking on the origin, the line will attach itself, even if the origin does not lie in the same plane. I didn't have to use the Tab key. I simply click on an existing point and the 3D sketch will connect to it. Now to define the sketch. The first thing is to align these 2 points using the along X relation. As well as these 2 points. Next, I want this small angled line to be perpendicular to the angled plane. This way, it will be parallel to the other short segment. To accomplish this, I'll select the angled plane and the line and select the perpendicular relation. When working with 3D sketches, it's common to use planes as references for geometric relations and for dimensions. For instance, the next thing I want to do is dimension this line from this point. However, if I select the point, I don't get the dimension to align the way I want. Instead, I get the shortest distance between the two. To get the alignment I want, I can select the front reference plane from the Feature Manager and dimension to the line. This gives me the alignment I was looking for. I'll finish up with a few more dimensions and some fillets. Remember to use the Tab key to make sure the dimension is applied in the correct orientation. There you have an example of creating 3D sketch geometry on angled planes. In addition to using the default planes or creating your own reference planes for use in a 3D sketch, there's a special type of plane you can create on the fly while in a 3D sketch. This is not the same as a reference plane. The main difference is that reference planes are fixed in space once you define them. Planes in 3D sketches are not. They can be defined using dimensions and relations just like any other sketch entity. Let's take a look at an example. Here I have a 3D sketch with 3 line segments already created. These are aligned with the X, Y, and Z axes and are here primarily to help us with visualization in 3D space. To create a 3D sketch plane, you can use the plane icon from the Sketch toolbar or from the Tools Sketch Entities drop-down menu. Notice the difference between this and a reference plane, which is found in the Insert Reference Geometry drop-down menu. The Plane Property Manager will appear showing selection windows for first, second, and third references. In a moment, we'll see how these references can help you define planes as you create them. In this case, I'll simply click OK and a plane is inserted into the sketch. Notice the Sketch Property Manager lists the plane with a minus sign in front. This minus sign indicates the plane is underdefined. If this plane were any other sketch entity, it would be shown in blue, indicating that no relations or dimensions had been added. Because the plane is completely underdefined, I can use the plane manipulators, these yellow dots, to move and rotate the plane in 3D space. Just like other sketch entities such as lines and arcs, I can use geometric relations and dimensions to define the location of the plane. For instance, I can show the front reference plane and make the 3D sketch plane parallel to the front plane. Next, I can put in a dimension. Be careful when using dimensions that you're accomplishing what you want. For instance, if I put in a dimension from this point to the plane, what I've done is tie one undefined entity, the point, to another undefined entity, the plane. Now when I move one, the other will move along with it. This is much different than putting in a dimension from the same point to the origin, or the front reference plane. At this point, let me add another plane, this time using references to position it right from the beginning. I'll click the plane icon on the Sketch toolbar, and for the first reference, I'll select the vertical line. When the line's selected, the applicable geometric relations will appear below the selection window. In this case, coincident, perpendicular, and parallel are available. I'll select coincident. For the second reference, I'll select the right reference plane from the Feature Manager tree and specify a 45-degree angle. You have the option to specify a third reference, but in this case, I'll click OK to complete the new plane. One of the main reasons you'll want to use planes in 3D sketches is so you can sketch on them. In order to sketch on one of these planes, you first have to activate it. To activate a plane in a 3D sketch, double-click on it. You'll know the plane is active because a yellow frame will appear around it along with the yellow control points. While a plane is active, any sketch entities you create will be on the active plane. To deactivate a plane, double-click in open space or double-click another plane.